In the last video, we talked about radius, sine, and the cosine function. Now I want to talk to you about the tangent function. Now what's powerful about all of these things is the following. So I'm just going to say so what's powerful about this is the following. If we know x and y, all we need to know are these two coordinates. Okay? Just for a plane. From that, we can use Pythagorean's theorem to calculate its distance from the origin. And then we can use the sine function, or we can use the ratio of y over r to define the sine function, and we can also use the ratio of x over r to define the cosine function. Kind of sweet. It's just real simple. And now if we define the tangent function, that's just going to be the sine function over the cosine function. So if you know the sine function and you know the cosine function, hey, you know everything. It's the tangent function. Now we can just place this in, we can say, okay, well, since we know the sine function, this is y over r. And since we know the cosine function, this is x over r. We can do this. We can say, well, let's multiply this by 1. If we're going to multiply this by 1, we'll just have r over 1 divided by r over 1. So you can see that these two are just basically 1s. And so I can just go ahead and say, well, r over r is defined as 1, and r over r is defined as 1. So we end up with y over 1 divided by x over 1, which is just 1 goes into y, y times, 1 goes into x, x times. So you can just see that we can just reduce this even further to y over x. So if we use the same example that we've been using, 3, 4 for our x and y coordinate, then the tangent function of the angle under consideration is just going to be y over x, which is just 4 over 3. And what is that? 4 divided by 3, 1.33. And it just continues. .33. All right, and that's it. Believe it or not,